Hi, geometry people. I hope you enjoyed the exploration while you did your exploration.
It's always kind of
And
fun.
now what we're going to look in the
The
next
next kind
section
of transformation
is
we're going to be looking at are
transformation we're going to be doing is
and
reflections.
so we want to look at
and they
sort of the more
pretty sure
technical
you know
side of what
basically
a
what a
reflection
transformation
is.
with the mirror. You saw how to kind of play with making a reflection. So what is a reflection? Well, we talked about isometries before, which is basically a rigid mapping. So reflections are going to be also isometries, so isometric mappings, and they have a few properties. The way these properties work, and it's important to know these because you'll be able to do constructions using these properties, we have two examples over here. If a point P is on the line of reflection, so like you did in the exploration, so if it's on the line of reflection, like we have here, then notice P equals P prime. So the pre-image and the image are the same. If P is not on the line of reflection, is not on the line of reflection, then what happens is you have the line that connects P and P prime, this line here, is going to be equidistant and perpendicular to the line of reflection. So you have, P is not on the line of reflection, that line is the perpendicular bisector of the segment P prime. So it'll be equidistant. So when you were doing in the investigation, when you were reflecting over the y-axis or the x-axis, you were always reflecting the same distance when you moved over the line. But we are going to be moving different lines, so it's also important that you remember how to graph a line. So for instance, if I were to graph the line x equals 3, since it's x equals 3, it's going to go through the x-axis, so it would look something like this. And what we want to do is we want to reflect this triangle. So let's go ahead and graph that triangle. So we have 1, 3, which is A. We have 5, 2. That's going to be our point B. C, which is 2, 1. So here's this triangle. Whoops. Let's go back and redo that line. Here's AB, here's C. And if I'm going to reflect it over that line, then we want to move the same distance. So A is a distance of 2 perpendicularly from the line of reflection. So A prime is going to be over here. B is going to go to the other side, which would be over here. And C, which is just 1 away, will be down here, and then you connect your vertices. So that would reflect it over the line x equals 3. So you're always looking in terms of a perpendicular distance and then going that same distance on the other side. If we wanted to reflect that same triangle, so I'm going to draw the triangle first. Let me see, A was at 1, 3. Here's A. B was at 5, 2. C is at 2, 1. So here's this one. Now we're going to reflect it over the line y equals 1. So that means you're going to intersect the y-axis, and notice that your C value is going to be on the line of reflection, which means that C will equal C prime. And when we reflect it over, we are going to have A now is going to move 2 spaces exactly down. So here's going to be A prime. B is going to go onto the x-axis. So this will be B prime. And when we connect our dots, I forgot to connect my other dots. Here was our ABC originally. That would be our reflection over the line y equals 1. All right? So reflection is going to be an isometry. Now, hopefully you noticed when you did the investigation that there are rules that through doing several of these, you should notice the same kind of pattern. And we wrote those rules when we did, when I hopefully went over the key to the expiration. So when you're going over the x-axis, reflecting over the x-axis is in that direction, so your particular x-coordinate is going to stay the same. So you're going to start with a pre-image that has an xy coordinate. When you go over the x-axis, your x value stays the same, but your y value is going to become the opposite of whatever it started with. When we went over the y-axis, which you did in the expiration, you should have noticed that the y-coordinate, the height of your value was the same, but what happens now is your x value becomes the opposite. So for instance, in this diagram here, let's say here's our pre-image point. So when I go over the x-axis, here is your xy reflected over the x. When you're going over the y-axis, here is the negative xy. And when you go over the line y equals x, now remember, I don't know if you remember much about inverse functions, but inverse functions are reflections over the line y equals x. So what happens is you start with xy, and your reflected image switches those values. So now you have y comma x. And it's not showing on this picture because there's a lot going on, but if I were to graph y equals negative x, that comes down like this. And now not only do x and y switch, so you would start with xy, that's your pre-image. You would not only switch the x and the y, but they would both become negative as well. So for instance, this is the point 4, 1. Now we're going to go to -1, -4, and that would be a reflection over the line y equals negative x. Now hopefully as we move through this chapter, these will become kind of intuitive, but you are going to want to remember them, and it's helpful if you kind of remember the rule, but if you don't, do just a basic reflection to kind of remember what the move would be. All right, so let's practice a few of these. We have graph ABC and its image after a reflection in the given line. So we're going to start with A is at 1, 5. So here's A. B is at 4, 4. C is at 3, 1. And remember we talked about you always want to label your points and also the pre-image and then your final image. So we are going to go over the y-axis and we're going to write what A prime, B prime, and C prime then will result in. So since we're going over the y-axis, the y-coordinate will stay the same, but you're now going to have the opposite. So as a reference point, it's not a bad idea just to remember to write the rule, and then you'll become a little more intuitive with it. So this will become -4, 4, -3, 1. So -3, 1 is going to be our C prime, -4, this is a really small 1, 2, 3, 4. 4 here is going to be our B value, and A is going to be right on the other side. So here's A prime, and there's a reflection over the y-axis. Over the line y equals x, so it's helpful to draw your line of reflection, so that's where all your x and y values are exactly the same since y equals x. And let's go ahead, and our initial picture is going to be at 0, 2, so here's A. B is going to be at 4, 5. And at 5, 2 is going to be C. So we're going to reflect now over, and so remember when you're reflecting over the line y equals x, your coordinates basically will change. So we're going to have A prime is going to become 2, 0, B prime is going to become 5, 4, C prime will become 2, 5. So we have 2, 5 will be our C prime, 5, 4. So just on the other side. And again, if you actually were to draw a line between these, it would show between the image and the pre-image, it should always look like the line of reflection is a perpendicular bisector. So see, this should be the same distance and perpendicular across. So the last thing we're going to look at in terms of a transformation would be a glide reflection. And that is a composition where you're going to first do a translation, which represents the glide. So Q will become Q prime, and then that'll be followed by a reflection over the line of reflection, which takes us to Q double prime. So you have a translation that maps P to P prime, Q to Q prime, and then the next P prime to P double prime, Q prime to Q double prime. So that's all that a glide reflection represents. I think they're going to ask you to do a few in the homework, but we're going to do one right here. And it's really just doing one transformation right after the other. So let's start off with putting our triangle onto the grid. So you have 3, 2, you have 6, 3, and 7, 1, almost off. So here's A, here's B, here's C. And the first thing it wants us to do, so here's our rule, which says we're going to take our x values down 4 and, back 4, and our y's are going to go up by 3. So A is going to go back 4, 1, 2, 3, 4, and up 3. So we're going to be up here at A prime. So I'm going to go ahead and list out those coordinates as we go. So that's going to put us at -1, 5. And then B prime is also going to go back 1, 2, 3, 4, and up 3, 1, 2, 3. So that puts us at 2, 6. And then we have the C, which is at 7, 1, is going to go back 4, 1, 2, 3, 4, 1, 2, 3, which puts us at 3, 4. So that represents the translation. Now, the second rule they want us to do is they want us to reflect over the line y equals 2. So the line y equals 2 runs right here as it intersects the y-axis. And so if I'm going to reflect over the line y equals 2, A is going to go the same distance down. So since A is 1, 2, 3 away, 1, 2, 3 more, that's going to give A double prime a new coordinate. So that's going to be at -1, -1. There's A double prime. B is going to go the same distance down, so that's going to go down 6. It's going to go down 4 to hit the line of reflection, and then another 4 to hit on the other side. So that gives it a coordinate of 2, -2. And C is going to, whoops, I didn't mark C prime here. So C is then going to bump to the other side 2 over. It's going to put it right on the axis at 3, 0. And there's basically the result of doing first a glide in that direction and then a reflect over the line y equals 2. Okay? Last little bit is just looking at lines of symmetry. Now, when you are doing lines of symmetry, you're only looking at what lines you can draw within 180 degrees. So, a line of symmetry is where a shape can be mapped onto itself by reflection over the line of symmetry. So, just to put this, so it's where you can map a shape onto itself, by a reflection over the line of symmetry. Later on, we're going to be looking at rotational symmetry over the line of symmetry. Over the line of reflection, actually. By reflection over the line of symmetry. I think we can do that. All right, so these are pretty easy to see, actually. So in this first polygon, we notice that if I draw a horizontal line here, that if I were to reflect the shape over itself, I would get the same shape back. But do you see another line? I could also draw one right down the middle here, and if I reflected it over that line, I would also have exactly the same. So we say that this one has two lines of symmetry. And over here, we have ourselves a hexagon. So we can first notice that if I draw right through the middle, it would fold over itself. So that would be one line. And I could do that for each side. So there's two lines, and then there's three lines. And we only count the one line, so it doesn't count to then go to the other side. So that's three lines of symmetry. However, I can also draw a line through the angles. So I could draw this line here, or I could draw, let's see, if we can find ourselves another color. I can draw through this line here, through each of my angles, and hopefully you're getting the idea that in the end, I'm going to have 6 different colors here, so this would be 6 lines of symmetry. And that means you have 3 for the sides and 3 for the angles. And lastly, well, not quite lastly, second to lastly, we have this kind of odd shaped figure here. The only line of symmetry is just 1. And then lastly, this actually wasn't meant to be an actual shape, but we just have 1 line of symmetry through the butterfly here. And that's it. So I hope this all made sense. I know I went really fast on that because it's a video and I don't know how it plays, but this will also be up on School Loop in case you need to go back and write down any of the rules. All right, see you on Friday.